Hi guys, sorry, we just finished translations, and right when I was about to say we're gonna go on to the next video, it cut me off. So perfect, we have just finished the translation one, and remember this is nothing new, so that's why I'm going kind of fast. I'm hoping to get this video done in 2 videos, might be a little bit more, but we'll see how it goes from there. Go to the second section now, and we're going to do, what do we call it when a figure goes from a large figure to a small figure, or vice versa, small to large? An enlargement, a reduction, and mathematically we call it a dilation. So we call it a dilation. Dilations are to enlarge or to reduce. And if you remember the video with scale Ella and Scalio, we also use something called Scalio, called scale factor. You enlarge when the scale factor is greater than 1. You reduce when your scale factor is between 0. Let me put an SF here. Between 0 and 1. So if you have a scale factor, so let me write this, scale factor. If you have a scale factor that is greater than 1, for example, 2, 3, 10, 5, your image is going to enlarge. When you have a scale factor that is between 0 and 1, that means 1/2, 1/3, 1/4, 2/5, 3/10. Anything that is more than 0 but less than 1 whole, that is going to reduce your object. It's almost in a sense like dividing, but we call it a reduction by multiplying. Scale factor means to multiply. If you can remember, this is one of the most important words that you can remember for this test, multiply. Scale factor means to multiply. Remember, I'm a superhero, and my superpower, I have a superpower, scale factor, and scale factor means to multiply. We stood in front of the room and we kind of looked a little funny doing it. So when we look at this, our algebraic representation means take the original point. Remember, it always starts with the original point. They try and trick you sometimes. They'll switch it. Always start with the original point. The arrow means change, and this is when we get this. And we still have an X and we still have a Y. But in this case, since it's multiply, we're not necessarily adding or subtracting anymore. We are multiplying. We're multiplying by K. We're multiplying by K. This is your scale factor. So K is equal to your scale factor. And we're almost done. K is equal to your scale factor. That means whatever we're going to multiply by goes wherever you see the K. And this is not on your formula chart, so you guys have to know what it looks like. So when you're looking for a dilation, you're always going to look for an algebraic representation that has a number and the letter right next to it. No add, subtract, multiply. No add, subtract, or divide. Only multiply. So let's take a look at this picture right here. And what I would like to do to this picture is, first of all, I would like to write our algebraic rule. So right here we have the original point, y, xy. It's going to transform into a dilation. And we know we're going to do something to the x, and we know we're going to do something to the y, and we know we're going to multiply. But we need to figure out multiply by what. And first thing I want to know, did this go from big to little or little to big? And I'll give you a hint for those of you that don't know. If you circle the letters, you can see right there we go from A to A prime. This one went from big, I'm going to put it right here, big to little. So if it's big to little, we need to figure out how big and how little. So you need to figure out the scale factor. So what you're going to do is you're going to pick the 2 points. So the first point that you saw here was A. A means the original. A prime is the new image. The pre-image, the new image, or the original and the old. So what we have here, this one is going to be 0, 6. And what is the A prime? A prime is 0, 3. And I bet you're going to remember something we talked about. We called it new over original. Remember that? New over original. So what you're going to do is either pick the x's or pick the y's. In this case, I would probably pick the y's. Why? Because the x's are zeros. So why pick the zeros? Pick the y's. So I need to know which is the new and the original y, which is the new y and which is the original y. The new y is 3, and the original y was, for the a, was 6. So now that you have new over original, you simplify it, which leaves you 1/2. Excellent job. That means that our scale factor of this image is equal to 1/2. Now, how do I take this 1/2 and write it in my representation up here? Correct. You put a 1/2 in front of x and a 1/2 in front of y. Could I put 0.5? Sure, whatever you'd like. But the scale factor always goes in front of the number, and it must be the same scale factor for both. So as we're looking at this real quick, would you say that these two triangles are congruent or are they similar? Dilations create similar shapes, not congruent shapes. So right here, we're going to write dilations create similar figures. Figures, not congruent. Similar figures mean they are the same shape, but not the same size. They have the same angles. All the angles are going to be the same. All these little angles are going to be the same, except the sizes of the shapes are not going to be the same. But the angles will still remain congruent. But the size of the shape is not going to be the same. So real quick, we're going to just come back to the side right here. And if you would, write this down, x, y. And we're going to do one here, and we're going to do 5x and 5y. And then right next to it, we're going to do one more, and we're going to draw a little line there. So the x comma y, the original was changed to 1/4 x, 1/4 y. All right, so tell me about this. What can you tell me by just looking at this? What is the scale factor? Correct, scale factor is 5. And was this an enlargement or a reduction? This one was an enlargement because it was greater than 1. So this is enlargement. This will help you eliminate answer choices when you're doing that. So what about the last one? Scale factor is 1/4. There's some questions that are that easy. What is the scale factor from the algebraic representation? So here you can see that it's 1/4, and it's 1/4 and it's less than 1, but it's greater than 0. So this is a reduction. It got smaller. Excellent. Reduction. And so that I can finish this video on this one, I want to go back really quick to the translations. Back up here to the translation. Real quick. Original and the new, are they congruent or are they similar? Both shapes are congruent. The size did not change and the shape did not change. So here, shapes are congruent. Shapes are congruent. Now I have one more thing. Did the direction of the shape change? Like, did it rotate or did it turn? Was it orientated or did the direction change? No, it stayed the same. A is on top, A is on top. B on the left, B on the left. C on the right, C on the right. No direction. I'm going to squeeze it in. Change. So on translation, the shapes are congruent and there was no direction change. On dilation, the shapes are similar. The shapes are similar. Now, did the direction change? No. So we got to put that here. No direction.